Hi, welcome back. English subtitles are available on this video. English is not my native language, so these subtitles might be helpful. A French version is also available. You will find the link in the description. In the previous video, we tried to get an intuition of machine learning. In this video, I will try to present some of the most common taxonomies, understand categorizations of machine learning. Taxonomy by dataset requirements, supervised learning. In supervised learning, the dataset must contain example outputs. We can illustrate this idea with an optical character recognition software where the dataset consists in images and their text annotations. These text annotations are our examples or labels. The labeling in supervised learning requires a supervisor, hence the name supervised learning, the supervisor being the entity that associates the data with the labels. Taxonomy by dataset requirements, unsupervised learning. In unsupervised learning, no example outputs or labels are required. The algorithm tries to discover patterns or similarities within the dataset. For example, we might use a non-supervised learning algorithm to try to discover which products are most commonly bought together by the customers of a shop. Taxonomy by dataset requirements. Semi-supervised learning. Semi-supervised learning mixes unsupervised and supervised learnings. For example, imagine a face recognition software which also tags the name of a recognized face. It might use a non-supervised learning algorithm to recognize the face from image to image and then require just one labeling of the face on one image, and it will be able to label the name of the face on the other image. Semi-supervised learning is useful when we have a small amount of labeled inputs and a much larger amount of unlabeled inputs. This reflects the fact that generally collecting data is cheap but labeling is expensive. Taxonomy by dataset requirements. Reinforcement learning. In reinforcement learning, no initial dataset is required. Data is collected instead by interacting with an environment. Thus, the algorithm makes its own measurements. Reinforcement learning is based on iterative enhancements in achieving a goal. Taxonomy by data provisioning scheme. Batch learning. In batch learning, we must provide all examples during the learning phase. In this setting, when we get new data, we must train a new model from scratch. For large datasets that cannot fit entirely in the memory of a computer, some strategies are needed in order to cope with batch learning. A mini batch learning algorithm consumes data by small subsets. A stochastic algorithm consumes one element at a time and picks this element according to a probability distribution. Finally, some data access and management methods allow to load in memory only the data needed for a calculation at a given time. Taxonomy by data provisioning scheme. Online learning. A prediction function resulting from an online learning algorithm can be used even after a partial training. When we obtain new data, the training just continues and enhances. The algorithm can adapt its representations progressively. However, we must notice that online learning is not always possible. Sometimes we can find a pseudo-online learning algorithm based on recursive algorithm, but nothing is guaranteed. Taxonomy by mathematical representation. Model-based learning. A model-based learning tries to generalize from the training examples. The result of this generalization process is the model that we will use to make estimations on new data. We discussed the notion of model in our previous video. You can find a link in the description. Taxonomy by mathematical representation. Instance-based learning. An instance-based learning algorithm compares new data to the training examples. Making estimations generally involves determining the closest neighbors of the new data among the training examples. Estimations can be done by voting or averaging. In voting, the estimation is equal to the most common value among the closest neighbors of the new data, and in averaging, this value is just the average value of the closest neighbors. Taxonomy by task or goal. Regression. Regression tries to estimate a value of a property. This value depends on the value of other properties of the data or other instances of the data. For example, we might use regression to try to estimate the incomes of an ice cream seller depending on the temperature forecast. Regression is typically a supervised task. Taxonomy by task or goal. Classification. Classification tries to estimate boundaries in the dataset so as to separate the elements into a number of classes. These classes are known or defined before the training. For example, an optical character recognition of digits is a classification task where the classes are the digits themselves. Taxonomy by task or goal. Clustering. Clustering tries to gather data elements into groups. The groups are not known before the training. They are to be discovered by the learning algorithm. These groups are called clusters. For example, we can use a clustering algorithm to try to discover customer profiles for a shop. Let us notice that the goal of clustering is to discover the groups, while the goal of classification is to dispatch the elements into existing groups. Taxonomy by task or goal, association rule learning. Association rule learning tries to discover how actors or agents associate items together. Association rule learning makes a grouping, but let's notice the difference with clustering. The grouping of clustering is based on the properties of the data, while the grouping of association rule learning is based on actions of third parties. For example, association rule learning can be used to determine which products are most commonly bought together by customers in a shop. Taxonomy by task or goal, decision making. In this task, we try to optimize a decision process. The goal is generally to maximize a gain. For example, we can try to make a software learn how to win at a game. This task is used in domains where strategy is important. For example, politics, business, or games. Decision making is typically learned by reinforcement. Taxonomy by task or goal. Blind source separation. Blind source separation tries to decompose a measurement into its basic components. The measurement is often a time series, like a sound record. For example, we can use blind source separation to isolate on different tracks each instrument of a musical composition. Taxonomy by task or goal, dimensionality reduction. Dimensionality reduction tries to reduce the number of properties used in our algorithm by removing irrelevant features. A feature is a mathematical representation of a property of a data. Dimensionality reduction can be used to reduce the number of inputs of other algorithms or to visualize the data if the number of components can be reduced to 3 or less. For example, in an optical character recognition of digits, we can decide to remove the color information and keep a grayscale image. This will divide by 3 the number of inputs of our algorithm while keeping an image still recognizable. Taxonomies of machine learning. Conclusion. Thank you for watching this video. There was a lot of information for this topic. I had to make a very condensed video. The first version made an hour. I discuss this topic in details on my blog. You will find a link in the description. You will get a much deeper insight. If you found this video useful, please like, subscribe and share. Thanks again and see you soon.